let's get started. So you have started to use already two methods, layer method and FMEA. Now, in this particular lecture, you are going to another method, QFD for PSS, right? QFD is complementary to FMEA. I am sure that at least some of you have learned QFD in product development course, and FMEA and QFD are complementary to each other, even in the PSS context. So, one challenge to be able to use QFD is to know what service is from the design point of view. You need to be able to design a service. Then to do so, you need to have what are the characteristics, what are the parameters for a service. You will learn that. Then a method, QFD for PSS. This is what you're going to learn. And in this lecture, I'm going to share with you a bigger method that involves QFD for PSS in it. Thereby, you can learn sort of broader framework or procedure to conduct improvement of PSS, right? So what is the cornerstone? It's traditional QFD, quality function deployment, which was developed mainly for products and partly for service, but not for PSS. So that's that's the gap. That was the gap that we filled. But just for a recap, QFD is based on the idea of market in. So taking in the customer's voices and translate them into design parameter so that the more important customer values are reflected on more important design parameters so that designers can focus their effort into those more important aspects. Was developed in Japan by some colleagues, for example, Professor Gao, quite early, already 60 years ago. And thereafter, this method was disseminated all around the world. And it's recognized the usability, usefulness, and so on. Right? So, let's dive into the question I mentioned at the beginning. So, what are the service design parameters, service design characteristics? I think it's relatively more difficult than in the case of product design parameters because a product is a physical one, and also you can touch and you can feel, you can see. Therefore, it's more easy to understand the parameters that belong to a given product. But let's think about what are the possible design parameters. In this slide, you will see 6 or 7 categories for such design parameters for a service. But this slide doesn't mean that these are the only categories, but there can be other categories. So don't limit yourself in seeing this slide. So let's start with responsiveness. As I said several times, when it comes to service, time is a crucial factor. Huh? And then how fast a service technician or service staff can respond to a given need is a relevant aspect. And a designer can decide how fast the service should respond to a given need. this is especially relevant when products have a sort of critical role in the customer's process and so on. So next, labor intensity. What it means is service can be supported by other components. For example, obviously products, but also software as well. And a given service can be described in terms of how much personal activity, human activity dominates the service, okay? And this has a big impact on the cost depending on the context, especially in Sweden and Europe. Labor cost is typically much higher than the cost for products, physical things, in many cases. Therefore, if the labor intensity becomes higher, the service cost tends to be higher. So therefore, it's relevant, and a designer can decide this. You will see the how the labor intensity can be adjusted or adapted in the next lecture, dealing with the product-service interdependency. Right? That's about the next lecture. But next one, customizability. I hope you remember that I mentioned the characteristics of the quality of service. There I explained that service quality should accept the variety depending on the customer needs, specific customer needs. Which means that service is expected to be customized and even tailor-made depending on the customer's needs. But earlier, I also mentioned that standardization is important to make the service economically viable. So there should be a middle point in between. That's why this customizability is an important aspect. A designer should decide how much customization a service should allow. A company providing services could provide sort of a very, very individual tailor-made services for each single customer. But if they do that, it becomes maybe too costly. Therefore, such a service provider can and perhaps should limit the level of customizability. Affordability is very much related to what I already explained. It's related to cost, how much cost and price is associated to the given service. And security, it's related to information sharing and also information integrity, because service tends to exchange information between the customer and the provider, and this aspect can be very important, and designers should take this aspect into account. Reliability, we already discussed the possible uncertainty and risk caused by the uncertainty, and the reliability can be set for service at hand, okay, by different means. So that's what this means. Modularity, how much a given part of the service can be modular so that different modules can be combined or exchanged to a given need. Okay, so these are examples of the service category, service design parameter categories. And do you have any question for any of these? Or the idea of service design parameter, service characteristics? Yes, please.
How is the customization and modularity different for each other?
Difference between so the question is the difference between the customizability and modularity. They are related, and so the difference is, I think, from the difference lies in the perspective. The customizability is, as I said, how much it's possible to sort of change the degree of variety of a given service. Then modularity is more of a configuration point of view. So let's say there are different, let's assume there are different service, there are modules that are possible to be used for a given service. In order for that to happen, service must be modular to start with. So I hope it's clearer now. Okay. Any more question? Then do you think of any other service design parameter category? There can be others. Okay, this is probably the question that you can think of in your project work. Okay. So now I'm going to start with the broader procedure that I mentioned, which includes QFD for PSS in it. And I just want to introduce how my group, our group, together with my colleagues, developed this procedure. So we started to observe the need for such a method that can handle a product service system, not only product alone, but I mean not only product alone or service alone, but such a method addresses product and services in the system both. And then we started with theoretical exploration, what could be such a method. And then we came up a proof of concept, POC, for such a method. Let's say 17 years ago. And then we tested the POC with a company based in Germany. The application will be explained in this lecture very soon. And then after the application, then we validated the method, and then we introduced the validated method into a different company, which is also manufacturing complex products and providing services. And then we helped the company implement the method within their existing work procedure, workflows, so that the outcome of their PSS offerings be better. Okay, so this is a sort of overview of the history of the research that we went through. So you know that the method or procedure that you are going to learn in this lecture and also in the other lectures are sort of validated from industrial point of view. So we call the procedure SPIPS, and it starts with analysis of customers, step 0 on the left-hand side. And step 1 at the top, you may want to segment different customers. And extract customer values or sometimes customers' cost or customers' risks as well. And as I added here, customer activity cycle, CAC, this is what I assume you have already done. Right? You, at least to some extent, analyzed the customers that you are considering, and you extracted customer values. Right? And here, one step that you can add is sort of a quantitative analysis of the set of customer values. That can be done using this 2x2 matrix. This is quite popular in industry because in industry always the resource is limited. They want to focus on more important ones and more feasible ones. And so let's say you have multiple customer values that you are considering, okay? And each customer value can be assessed in terms of two dimensions. Number one, importance for the customers, okay? The other dimension is the level of current satisfaction of the customers. So apologies for the colors of the font for the two dimensions are hard to see, but what I said is written on the slide. So on the horizontal axis, less important on the left-hand side, more important on the right-hand side, okay? And for the vertical axis, more satisfied currently is for the upper half, and less satisfied is the lower half of the matrix. So then you see 4 different areas, right? And so for example, in the, let's say, in the left bottom area, less important, and even though the current customers are not so satisfied, but it's less important, then probably we shouldn't focus so much on the left bottom area. And if you go to the more important and also the customers are relatively more satisfied with, then maybe we can just continue. Huh? And probably the most interesting area is the right bottom. So that means the given customer value on the right bottom corner is more important, but customers are currently not so satisfied. Okay, so important, but not yet not so satisfied. Then this gives an opportunity for improvement. Okay, so in order to so you are expected to collect the data for the 2 dimensions, and then plot all the customer values on this 2x2 matrix, and then you will get the results. Okay, so these customer values are the what we should focus on for the improvement. Okay, so by going through this exercise, you can have more focused investment for the improvement, and the outcome of such exercise can be input to step 4. Huh? Step 4, this is where QFD can be applied. The purpose is translating the customer values into design parameters. Okay? And so QFD for PSS can consist of 2 phases. The first phase is correlating the customer values on the left-hand side, you see, and the characteristics of products or characteristics of services at the top of the matrix on the left-hand side. Okay, so in the matrix, you give differentiation in terms of the correlational strengths between a given customer value and characteristics. Right? And of course, the difference with the traditional QFD here is we need to have design parameters for the services here in the matrix. Okay? Without that, it is very similar, almost identical to the traditional product design QFD. Huh? So the new feature of QFD for PSS lies in the blue shaded parts, okay, of the matrix. And phase 2 aims to correlate the design characteristics and the components of the products and services. Any question for this? If you know traditional QFD, then I think you will be rather easily understand. So the extension is the addition of the service aspect. Okay, and as I said at the beginning, you can use the service design parameter categories when you describe the service design parameters here. Okay. Obviously, when you handle a specific PSS, then the service design parameters also must be specific. Okay. But I'm sure that you understand that. Okay. Then another new feature probably is how to describe components of services. In the case of components of products, it's I think easier. For example, one component of passenger car is an engine, right? Tires. So those are physical components, physical entities. But then what is then such entities for a given service? It can be different ways of describing such components for a service. But one of our papers suggests that components of a service may be human resources, information, or service tools. So the important point here is we want to describe an entity for a service, which is different from a characteristic. Okay? A characteristic is a parameter which has a dimension, a unit, but component is an entity. I hope I'm making a clear distinction between the components and characteristics. Okay. So by looking at the examples for each category, I think you will better understand. For example, service technician. This belongs to a human resource category. Okay. This is an entity required for a given service, and online support staff, and so on. Information is another type of a component. Service manual, information for the product usage history, database, that belongs to the information. And service tools could be, for example, repair tools, physical tools, and it can be data analytic software. Of course, these are the sort of abstract categories, and then if you if you conduct phase 2 of QFD for PSS, then you need to concretely describe the components for service at hand. Okay. Any question? Oh, yes. Yeah.
Is there any commonality between the components of the products and service components?
So the question is there any commonality between the components of products and components of service? Commonality is I think once again, excuse me for using the term entity. I think that is an overarching concept. It's an entity that is a part of a product. Is, for example, engine in the case of passenger car, no? And that applies to the service as well. So let's say maintenance service. There must be a maintenance technician. That's one entity. And a maintenance technician usually brings some toolkit. That's another entity. So I hope I answered your question. Okay, good, thank you. And then you.
Give an example of characteristic of a service to help draw contrast between a component and characteristic.
Give an example for this.
Characteristic of service.
Okay, this one.
Compare with the component of service.
Okay, yeah. So, and then let's go back to the examples of this. No? Okay, let's see. Okay, let's take this as an example. Responsiveness, repair service. So we think of repair service as an example, and a designer should decide how responsive the service should be. Huh? And as we discussed, entities required for the maintenance service can be maintenance technician and maintenance toolkit, information, and so on. So responsiveness is one aspect that can be measured and also that can be controlled by a designer. But then service components exist on a different dimension that are entities. Right? So each entity can be also somehow measured from the responsiveness point of view. So is it clear now? Okay. So the other examples are also such that these characteristics are parameters and the components are entities. Okay. More question?
So this question is for the benefit of all. While identifying the service characteristics in QFD, so you have specifically talked about three ways that you can think. One is the human resource, other is the information, then comes the service tools. Now I'm giving you a situation that, okay, I buy a Toyota car and the car manufacturer tells me to install their app in my mobile, through which they are actually maintaining a customer relationship with me. And all my service requirements, they want me to do through that particular app. So when I talk about this app, in which category you think that it will fall into? Information and service tools. Because I see the moment I talk about that particular app, it will also have the information characteristics. It will also have the service tools.
Yeah.
So what is your take on this?
Yeah, I would say such an app is primarily a kind of service tool, But what is a bit complicating is such an app uses information typically. And then that information should be the type 2. No?
Okay. So maybe when we actually try to put it in the QFD, so maybe we should be able to disintegrate the features of the app itself and then start discovering the information and the service tool aspect of it. But as a whole, the app would come under service tools.
Yeah. Yeah.
Thank you.
Yes. Thank you, Pratul, for your question. One important thing to be conveyed to you is the order of addressing the characteristics and the components. The characteristics are addressed first before the components are addressed, because the characteristics are closer to the requirements, okay? And these are more abstract, okay? Depending on, for example, responsiveness is one of the service design parameter category, okay? Depending on the designer's decision on how responsible the service should be, required components for a service are different. No? So if the service designer wants to make the service very responsive, very fast response, then they require perhaps service tools like connectivity and analytics and so on. So this is, I think, one important message taken from this QFD procedure. So the order is not at random, it's rather deliberately chosen. No? Okay, good. And one example for QFD for PSS phase 1 may look like this. The customer value could be, in this case, was used for the grass cutter and the related services. Customer value could be easiness to understand how to use the product, small space to store, easiness to set up, variety of cutting modes, short time to trim, uniformity of trimming, availability, convenience at the end of use, the cost of accessing to trimming. Do these make sense as customer value? No? So once again, be reminded that these are from the customer's point of view, and each of these should be shouldn't assume any solution. Right? And then going to the characteristics, product characteristics could be size of the trimmer, weight, mean time between failures, modularity of the product, speed of cutting, stability, physical stability, and product manual. So these are the, well, I would say the availability of the product manual, to be precise. No? When it comes to service characteristics, here, quality of information provided. For example, how detailed should be, and so on. Quantity of information provided. For example, it shouldn't be too many pages in manual, and so on. Calendar time of response to inquiry. This is exactly a kind of responsiveness. No? Calendar time of maintenance, variety of services provided. This belongs to the customizability service design parameter class. No? Quality of service manual. Do the characteristics make sense? No? And as in the original QFD, the matrix should receive the numbers 0, 1, 3, or 9 to differentiate the level of correlational strength between each customer value and a characteristic. No? And the calculation is the same from the traditional QFD. You will multiply together with the weighting for the customer value. You have access to a spreadsheet file that has already implemented the calculation formula here. So it's straightforward if you look at the calculation formula on that Microsoft Excel file. Any question related to this example? Okay, great. And the outcome of such QFD exercise is design focus, or FODC. And you should use such focuses, or FODC, for the brainstormings related to improvement. It's a designer's creative activity. Then outcome is possible solutions. Okay. And then step 6, you need to make sure that the derived improvement is economically viable, for example. And in that case, you may want to use life cycle costing, for example, or another assessment tool. Okay. And in that step, last step, you may want to also use the similar 2x2 matrix. Again, apology for the color of the fonts for the dimensions. So in this matrix, the horizontal axis is for the degree of improvement in terms of customer value, low, high, okay? And vertical axis is the amount of necessary investment, okay? High and low. So by using this 2x2 matrix, you can easily get support for rational decision making, right? It's obvious, no? These four spaces mean. Okay, good. Any questions so far? Good. Then I will explain to you the application case where I together worked with a company based in Germany, and we came up with some design solutions by applying this SPIPS procedure. So to start with the case, a small background of this company and their business. It's a manufacturer producing rather large-scaled products, complex products that need quite a high investment. It's not a cheap one, so the product is rather expensive. And well, typically the machine is computer controlled, and the availability is critical. So this is the sort of important feature for the product. And interesting thing is, at the time of the collaboration, the company had implemented the sort of infrastructure for digitization and also communication, information transmission, and also some sort of analysis. And the motivation of the company was to make sort of balanced investment between physical products and also services. So this is exactly, I think, a typical situation where the company benefits from product service system design. Okay? We started with a survey of the customer value. I mean, obviously, before asking potential and existing customers, we did analyze what are the customer values, customer needs. You know, do you remember the step 0 and 1 of SPIPS? So you are supposed to analyze the customers and analyze what their needs and what their wants are. And then we came up with, after that, we came up with about 12 customer value items. And then we did a survey using those 12 customer values. We asked the customers to rate between 1 and 7 for each customer value. And the result looks like this. So the most important customer value was quality of the final product. Final product means the product produced by the investment machine. So not the investment machine itself, but the outcome of the product produced by the focal company. Immediate availability. So as I said, the machine is time critical. So the customer finds immediate availability is highly important. And available operation time in terms of calendar. So these were the top 3 customer values. So then what the next step or the step 4 of SPIPS is, as I explained earlier, translating those customer values into characteristics of products and services. So as you see here, these are the top 3 customer values, and the numbers are given for the customer values. The numbers that you saw on the previous slide, the highest one is 6.8 and the lowest one is 4.8. So these numbers were input to differentiate the relative importance. And then here, product design characteristics and also service design characteristics are listed in the matrix, and then QFD table were given here, correlational matrix. Thereby, as an outcome, the relative importance of the design characteristics, right? So in this application, we used specific software. It's not a commercial one, developed by for academic purpose. And then we saw as an outcome from the software, we saw relative importance of design characteristics. So using the outcome, designers did brainstorming by looking at what improvement options can be possible to improve the more important design parameters. And it's up to the designers, and it's when this method, SPIPS, is applied in industry, then this specific part is depending on the capacity of the designers, and it's not really controllable. But anyway, in this specific case, the designers came up with these solutions. For example, number 1, machine end operation with less frequent malfunction, meaning that it mainly responded to the immediate availability, which was second most important customer value. And then they came up with a solution. Both the product and the service should be less frequent malfunction. And another example is stuffs with quick response. This also contributed to the immediate availability and also available operation time for the product. So just observe that these suggested solutions were based on the outcome of the QFD exercise, which uses the customer survey results. So the now for you understand the workflow of the SPIPs helps designers to find important design space consisting of important design parameters so that the derived solutions are really targeting the important customer values. Okay, so any question regarding the case? Okay, so I can give some highlights for this method called SPIPs. I think it's quite obvious that this can be applied to early stages and addressing both products and services, and the procedure as such is a sort of modular, meaning that some steps could be omitted. For example, performance importance matrix could be omitted, for example. So in that way, you can choose which steps you will conduct depending on the resource that is available. Okay. Any question regarding the workflow SPIPs that includes QFD? Okay, good. I just want to introduce another application case. We applied sort of several variants of QFD for PSS in different contexts. This is one such case and published in a paper. In this case, we included environmental aspects as a requirement so that the solutions suggested were also environmentally conscious. And then we compared the status quo versus the derived improved solution in terms of life cycle CO2 emission. So in this case, we compared the starting point and the ending point of using the method in terms of environmental aspect. Another case is taken from another research group. They use a variant, again, another variant of QFD. E stands for environment, QFD for environment. It's a variant of QFD. So the message here is the outputs of QFDE were effectively used for the SWOT analysis, which is very popular in industry, and supporting strategic decisions of a given organization. And so, I mean, as you know, the SWOT analysis, the outcome of QFDE can be easily integrated into the SWOT analysis. And in this case, they even applied a similar analysis called TOES. So with this example, I wanted to share with you QFD variants. QFD for PSS is one of them. Can be combined with other methods, which include strategic decision support tool, and so on. So in that sense, it's quite modular. QFD as such is modular. So meaning that it can be embedded in a certain workflow and another workflow, and so on. With that, I'm happy to take further questions from you. Hi, so just for clarification, you have access to one Excel file, which consists of 2 sheets at least. One sheet is for phase 1, the other is phase 2. And phase 1 sheet looks like this. So you type in the customer values for your own PSS and put numbers for the customer values and type in characteristics of product and services and put numbers in the matrix, and then you will get the relative importance of the design characteristics as a result, right? And phase 2 is for the components added, but probably due to the time limitation, our suggestion is to focus on phase 1. Okay? We think that is enough for using your learning outcomes with the hands-on exercise. Okay? Good. Thank you for your attention.